electric field due to an electric dipole along equatorial line or point, whatever you take. Okay. So in the last class we did something with respect to along the axis, right? So with respect to the dipole, what you are going to do now is, let me take minus q at position A and plus q at position B, and they are going to be separated by distance of 2d, right? So they are going to be separated by distance of 2d, right? So in the previous derivation, what we did is, along the axial line, we took a center point between minus q and plus q, and we drew a line at position P as the distance having r, right? The same you are going to do here. So what I am going to do is, I am going to consider this as O, the center point between minus q and plus q, and now since it is equatorial, I am going to draw a line perpendicular to the axis of this dipole, and I am going to place a point here to find out what is going to be the electric field due to this dipole at this position. Is that clear? Right? So now this distance is going to be r. Clear? Right? And when you have splitted this into two equal halves, this is going to be d and this is going to be another d. Right? Obviously what we have to find, what is going to be electric field at this position due to minus q and plus q, right? Yes. So let me take it for plus q first. So what the along, I mean with respect to this position P, the electric field due to positive charge will move outwards, correct? So what I'm going to do is, I'm just going to draw a line which is going to extend it in this way as E plus q. This is nothing but electric field due to positive charge, which is going to move outwards, because according to lines of force properties, the electric lines of force always move outwards from positive charge, right? And for negative charge, yes. So I am going to draw a line here for negative charge, where the electric field is going to move towards this charge. Clear? Right. So now what will be the electric field due to positive charge? What is going to be this electric field due to positive charge? What is it going to be? What is electric field due to a point charge? 1 by 4 pi epsilon naught q divided by r square, right? But what is the distance between this point and plus q? You don't know, correct? What we have to do, you know this is going to be right angle triangle, yes? And let me take this as theta. The same here, because it is equal halves, so obviously this right angle triangle will be equal to this right angle triangle, and you have r and d, correct? So by Pythagoras theorem, hypotenuse square is going to be adjacent square plus opposite square. So can I take r square plus d square, and it is going to be hypotenuse square, but I require hypotenuse. So can I take it as root? Yes. The same here, root of r square plus d square. So now what is going to be the distance between these two? R square plus d square root whole square. So again, can I take it as r square plus d square directly? Yes, I am just taking only the magnitude here. Is that clear? Right. So how about E minus q? 1 by 4 pi epsilon naught q, no, I am just taking the magnitude. So q r square plus d square, right? So both are going to have the same magnitude of electric field, correct? If you take minus here, when you add these two, it will get cancelled. It then means what? There is going to be an electric field which is 0, correct? But that is not the case, because both the electric fields are vector quantities. You cannot directly add it. Okay, so what I do is, I take this particular position alone. Okay, so see here, this is going to be E plus q, this is going to be E minus q, correct? If I take vector cases, this is going to be the directions, correct? So the resultant between these two will be along this direction. Yes or no? If this is going to be theta, this should also be theta. Why? Sum of interior and exterior angles are equal, correct? So this is going to be also theta. Likewise, this is also going to be theta. So if this is going to be a vector and if its resultant is like this, can I resolute that into two components, horizontal and vertical components, right? If this is theta, this is going to be horizontal component, correct? Either theta varna then adjacent. So this is going to be horizontal component, and what is going to be the vertical component here? This part. So can I take E plus Q sin theta here and E plus Q cos theta here? Yes. Likewise, the same here also. I can take E minus Q sin theta here and E minus Q sin theta here, sorry, cos theta here, right? So in this case, the magnitudes of electric fields are equal and the directions are opposite for sin thetas. Mala one kilo one podu equal magnitudes lo pochna. Can I cancel this? Yes. So the resultant is going to be what? E cos theta plus E cos theta, correct? So it's going to be 2E cos theta. So can I take the net electric field as 2E cos theta? You can take any kind of charge. You can take either plus Q or minus Q because both the magnitudes are same only, right? So let me take it as E plus Q cos theta. Is that clear? So we have to know what is going to be the cos theta value as well as electric field due to charge. We have found out what is going to be electric field due to charge. So can I find out what is cos theta? Okay, for cos theta, let me take this triangle. Okay, if you take this triangle, it looks like this. This is 90 degree, this is theta, this is R and this is D, correct? And this is going to be R square plus D square. From this, if I take cos theta, it's going to be what? Adjacent by hypotenuse. So what is adjacent here? D. Hypotenuse is root of R square plus D square. Good. So now I know what is cos theta. Now I know what is E, what is cos theta. Can I substitute that here? So what will get? 2 into E plus Q, you can write it like 1 by 4 pi epsilon naught Q by R square plus D square into D by R square plus D square whole power 1 by 2. Yes? 2QD, what is this? P, dipole moment, right? So I got dipole moment now, right, in the equation, that's it. So I rewrite the same equation in the next page. So you got 2 1 by 4 pi epsilon naught good. Okay. So in this 1 by 4 pi epsilon naught, let it be common, I will take it out. 2QD is going to be dipole moment. So P divided by R square plus D square whole power 3 by 2. Because when you are multiplying the values, the power will add. Correct. So 1 plus 1 by 2. Correct. So it's going to be whole power 3 by 2. So this is going to be the electric field due to an equatorial point for a dipole moment. Okay. Again, what we will do usually? We will take the distance as very greater than that of the dipole distance. So if R is very much greater than D, I can neglect D. So what will be the equation now? E is equal to 1 by 4 pi epsilon naught P by R square whole power 3 by 2. So this 2 cancels. You will be having it as 1 by 4 pi epsilon naught P by R cube. This is going to be the equatorial electric field due to an equatorial position, and I have considered only the magnitude. Okay. If you consider the vector, E vector will be equal to 1 by 4 pi epsilon naught minus P vector whole divided by R cube. Why minus? Because in this case This is going to be the resultant electric field. So the electric field direction is this way, but the dipole direction is opposite. So dipole will usually have the direction from negative to positive, but for electric field it always moves from positive to negative. So obviously they are opposite in directions, so there will be a negative sign to compensate that. Is it clear? Right? So this is going to be electric field due to an electric dipole along equatorial point. Okay, for axial point what we found? E vector axial was what? 1 by 4 pi epsilon naught 2p vector by r cube. By comparing these two equations, what we can arrive? Can I say E axial, magnitude alone, okay? Can I say E axial as 2 times E equatorial? Yes, or otherwise you can take equatorial as half of that of axial. So sometimes you will be given like the two charges separated by a small distance constituting a dipole has an electric field at a position along the axis as so and so. What will be the electric field for the same dipole if the position is at equatorial condition? So what you can do? Just divide it by 2. Okay, so you will find out what is going to be the equatorial electric field. Is it clear? Purida, right? So that's it. This is very, very important equation. நான் தான் மேக்னிடியூட் தான் எடுத்துக்கிறேன்னு சொன்னேன். டைரக்ஷன் வரும்போது தான் நம்மளுக்கு ஆப்போசிட்டாக இருக்கும். ஸோ பாசிட்டிவ் நெகட்டிவ் மாற்றிக்கணும்.